You've probably seen a pile of scrap wood at a construction site 1,000 times and never really given it a second thought. But what if I told you that pile of so-called waste is actually a key player in the new carbon economy? Today, we're going to dig into how we're turning discarded lumber into a seriously powerful climate solution.
Just look at this pile of wood. Every single year, construction and demolition sites all across Canada generate mountains of it. And where it ends up, well, that matters a whole lot more than you might think. This is the story of how we can take a major climate problem and flip it into a huge economic and environmental win.
And the scale of this is, honestly, it's kind of staggering. We're talking about 2.4 million tons of wood waste generated every single year in Canada. That makes it one of the country's biggest solid waste streams, just piling up. So, here's the crucial part. What happens next? When this wood gets buried in a landfill, it doesn't just sit there. Oh no, it decomposes without any oxygen and starts releasing methane, a greenhouse gas that's way, way more potent than carbon dioxide. So diverting this wood isn't just about saving space. It's about stopping some really serious emissions. All right, so here's our game plan. We'll start with the problem itself, then jump into the clean wood solution. After that, we'll get into the fun stuff, the carbon credits, and see why wood waste has this incredible zero carbon advantage. Then we'll look at how to lock that carbon away for the long term and wrap it all up by seeing how this builds a real circular economy. So let's get right to it. Let's talk about this simple but really powerful idea of clean wood diversion. First things first, what exactly is clean wood? It's a very specific category, sometimes called white wood. I want you to think of raw lumber offcuts, solid wood from framing, or untreated pallets. The key here is everything it doesn't have. No paint, no chemical treatments, no stains, and no glue. And you can really see the difference here. On one side, you've got that clean wood, which is just perfect for recycling. But on the other, you have things like plywood, OSB, or pressure-treated lumber. All those glues and chemicals make them much, much harder to repurpose, which really limits their recycling options. Now, the process for diverting this clean wood, it's actually really straightforward. It all starts right at the construction or demolition site, where it gets separated out. Then it's screened to get rid of things like nails and screws. After that, it gets ground up or chipped down to whatever the market needs, and boom, it's off to become something new. So you might be thinking, if the process is that simple, why isn't everyone already doing it? Well, like with so many things, it all comes down to incentives. The classic mix of the stick and the carrot. Okay, the stick is basically all about making landfilling the wrong choice. Some places like Metro Vancouver have just outright banned clean wood from their landfills. Others use financial pressure. They'll slap a huge fee on a truck full of mixed waste, but give a big discount for a load of pre-sorted clean wood. It just makes it cheaper to do the right thing. But, while sticks are effective, the carrot is where things get really interesting. This is the new frontier, transforming that diverted wood from just a cost on a spreadsheet into a high-value asset by generating carbon credits. And that brings us to a huge piece of federal policy, the Clean Fuel Regulations, or CFR. Basically, it's a system designed to lower the carbon intensity of fuels we use in Canada, and it's the engine creating this incredibly powerful financial reason to divert wood waste. It all boils down to this one question. How on earth does a pile of scrap wood from a building site get turned into a valuable tool for fighting climate change? Well, the answer is all in how we measure its carbon footprint. Okay, now just look at the number at the very top of this table. Under Canada's clean fuel regulations, different feedstocks get a carbon intensity score. Used construction and demolition materials get a default score of 0. That is a huge deal, especially when you compare it to crops grown specifically for energy. This 0 is basically a policy supercharger. It's like a cheat code. When you make a biofuel, say renewable natural gas, from this wood waste, the government considers its starting emissions to be 0. That just craters the fuel's total life cycle carbon score, which means every bit of energy it produces generates the absolute maximum number of compliance credits. And because of that magic 0 score, the credits generated are incredibly valuable. As the market got tighter, the price for a single credit, which represents 1 ton of CO2 reduction, was projected to shoot up to around $350. That 0 score is what literally turns a disposal cost into a major revenue stream. But creating low-carbon fuels isn't the only option on the table. There's another really powerful pathway for wood waste that takes us into the voluntary carbon market, locking its carbon away for good. The key technology here is something called pyrolysis. It sounds complex, but it's not. You take the clean wood, You heat it to a super high temperature in an oxygen-free chamber, and you create this stuff called biochar. It's a super stable charcoal-like material that basically freezes the carbon from the wood into a solid form, where it can stay locked up for hundreds, even thousands of years. This process is so effective that the major players in the voluntary carbon market have written the rulebooks for it. Big organizations like the Climate Action Reserve, Puro.Earth, and Verra will actually verify the process and issue carbon removal certificates. But, and this is a big but, there's a critical catch. To earn these credits, you have to prove something called additionality. That means you have to prove this whole thing wouldn't have happened without the money from the credits. If a landfill ban is already in place, making that claim gets a lot tricky. So we've got fuel credits, we've got carbon removal credits, but how do these abstract ideas actually translate into real-world impact? Well, this is where all the pieces come together to build a truly circular economy. Check out this fantastic real-world example. A company called Walker Industries takes old railway ties, a really tough waste stream, and turns them into a form of biocarbon. Then, the steelmaker Stelco injects this biocarbon directly into its furnaces, using it to replace some of the metallurgical coal they'd normally have to burn. Just this one partnership diverts 20,000 metric tons of wood from landfills every year. I mean, that is the circular economy in action. You're taking a major waste problem, all this scrap wood, and you're using it to help solve another massive problem, the huge carbon footprint of heavy industry, like steel manufacturing. It's just a perfect loop. So the story of clean wood really shows us how smart policy and new technology can completely change how we think about waste. It really makes you wonder, if a pile of scrap lumber can become a tool to make green steel, what other stuff that we throw away every day is just a resource we haven't unlocked yet?